Dear students, in this session we are going to see about electric dipole. Di means two, pole means end. When the two electric charges are placed at the ends is called as a electric dipole. That is the two equal and opposite charges. The magnitude of the two charges will be equal, but the nature of the charge is opposite. This is minus charge, this is plus charge. So the two equal and opposite charges separated by a very small distance. Here we denote that the distance as a 2a. So what is electric dipole? The two equal and opposite charges separated by a very small distance is called as a electric dipole. Whenever there is a electric dipole, the dipole possesses a electric dipole moment. The electric dipole moment is a vector quantity. So the value of the electric dipole moment can be written as P small p. It is a small p which is equal to magnitude of the charges. That is the magnitude of the both the charges are equal. So we can write the magnitude of the charge into that means multiplication of the distance between these two charges. That is the electric dipole moment is equal to the product of the magnitude of the charge and the distance between them. So since we know that the electric field is a vector, the electric field vector is always moving from positive charge to negative charge. That means it will move away from the positive charge and it will be moved towards the negative charge. So the electric field direction is from positive to negative charge. Then here the dipole moment direction is just opposite to electric field direction. The dipole moment direction is from negative to positive direction. So this is very important for exam point of view. Students, we already know that the electric field formula is equal to E is equal to kq by r square. Q is the charge and r is the distance between that point and the charge. Now we see the situation. This is an electric dipole. This negative charge has a one electric field and this positive charge has a one electric field. So what about the total electric field? What is the equivalent electric field of this electric dipole? That is electric field of an electric dipole along this axial line, that is a horizontal line. So we take a point, we consider the point P at the line joining the axial point. So if you extend this line along the horizontal, this point joins. At this point, what is the electric field due to this positive charge and what is the electric field due to this negative charge? So whenever we will say that in this equation electric field E is equal to kq by r squared, this r represents the distance between the point and the charge. So this is here we have the two charges, system of two charges. So we consider from the center O, the distance from the O and the particular point is r. So what is the distance between the two dipoles? That is the electric dipole is 2a. So here this is a and a. By substituting the electric field formula, the electric field due to the positive charge is equal to k into plus q charge divided by r squared. What is the distance between the plus q and the point P? This is the distance. So the distance from O to P is R. The distance from O to this point Q is A. So this R minus this A is a distance from positive charge to the point P. Hence we write that instead of R squared, R minus A the whole square. Similarly for the negative charge also. So the electric field due to the negative charge E minus Q is equal to K into minus Q divided by R square. R square is this R is a distance. So the distance can be written as what is the distance between the negative charge and the point P? The R plus A. Hence we write instead of R we have to write R plus A the whole square. Student, understand why we are writing the R minus A the whole square for plus Q and R plus A the whole square for negative charges. So at this point, at any particular point, the electric field due to the positive charge is moving away. This is electric field direction due to the positive direction. It will move away from this the positive charges. What is the electric field direction of the negative charge minus q? It will be moving in this direction. Hence the total charge is called as a E axial. That is electric field along the axial line is equal to, we have to add up the positive charge electric field and the negative charge electric field. Hence we substitute the E positive, that is electric field for the positive charge and electric field for the negative charge in this equation, we get that kq by r minus a the whole square plus minus kq by r plus a the whole square. Taking the kq commonly outside, we get 1 by r minus a the whole square minus 1 by r plus a the whole square. Hereafter it is a mere simple mathematical simplification. Just to take the LCM, r plus a the whole square and r minus a the whole square, we have to put minus here and multiplying the denominator terms as it is. So we get that r plus a, that means a plus b the whole square and a minus b the whole square. Just to expand, r square plus a square plus 2ra, that is a square plus b square plus 2ab. Then I will bring this negative sign inside this a minus b the whole square. Hence we get minus r square minus a square. So by formula we get only minus 2ra, but by including this minus sign inside this formula we get plus 2ra. Hence this positive plus r squared and plus a squared is cancelled with the minus r squared and minus a square. In denominator, this is r minus a the whole square and r plus a the whole square. That is r minus a into r plus a the whole squared. So this is a minus b into a plus b formula. What is a minus b into a plus b formula? That is a squared minus b squared the whole square. So I will write this is a minus b. This is a plus b. So we have to put the whole square. That is this square and this square will be taken as a whole squared. Hence we get a minus b into a plus b, which is equal to a squared minus b squared. That is r squared minus a squared. Then this whole square comes here. So by adding these two things, 2ra plus 2ra, it is a 4ra. Then kq into 4ra by r square minus a square the whole square. Now we get that E axial, which is equal to k into q into 2a into 2r. How we will get that? 4ra can be split into 2a into 2r. Then I will split into 2a into 2r. Hence we get q into 2a is equal to dipole moment. Substituting the dipole moment value here, we get k 2pr by r square minus a square the whole square. Hence we get the final expression E axial, which is equal to electric field along the axial point of the electric dipole, is equal to k 2pr by r square minus a square the whole square. When this point is considered as a long distance point, if the r is very greater than this a, we have to neglect a, because the r value is a very bigger value, then a is a very small. We can neglect this a in this equation. Hence a can be removed. Then r squared the whole square, which is equal to r power 4. Hence we get the equation E axial line, which is equal to k2pr by r power 4. Then this r and this 1r will be get cancelled. We get r cube. So the final equation for the electric field due to an electric dipole along an axial line is equal to 1 by 4 pi epsilon naught. This k value can be substituted with 1 by 4 pi epsilon naught into 2p by r cube. Hence the electric field is a vector. We have to multiply with the unit vector. This is the expression for electric field due to an electric dipole along the axial point. Next we are going to see about what is the electric field of an electric dipole due to an equatorial point. Equatorial point means perpendicular. Now you see that this is a negative charge, this is a positive charge. From the center, in previous case along the axial line, we put the point here. Now the point can be placed perpendicular to this dipole charges. So the distance from the origin to the point is r. That also we have to take in the axial point also. You see that from O to the point P is taken as R.